BTEC Applied Science, Unit 2, Calorimetry 3. I'd like to talk about the report, what you actually hand in at the end of the day. Now, this is not a checklist. I am not giving you a checklist. I'm just pointing out some of the things that students very often miss out or do badly that you should really focus on when you're writing your report. Your report should have structure, okay? It should be in different sections, very clear sections. You start with an introduction. What is this investigation about? On your assignment brief, you'll be given a context. Read that, and that should be part of your introduction. What are the aims of this investigation? Then we have a big section about choosing which thermometer you're going to use. I've talked about that already in another video. Then the main experiment, the structure of most investigations is you have your method, your results, your analysis, and your evaluation. They would be very good subheadings. I would start each of them on the new page, for example. The method, step-by-step method, like a recipe. How did you carry out the experiment? A detailed method. It should include, amongst other things, this isn't a definitive list of what you have to do. This is stuff that, students often leave out. It should include, what equipment did you use and why? Would you justify your choice of equipment? The actual container that the cooling down happens in is called a calorimeter. Now, you may just use a boiling tube. That's what I do, just use a boiling tube. That is my calorimeter. But why do I use that boiling tube? What size do I use? Do I have a lid on it or not? Justify your choice of equipment. Obviously, we've said what thermometer we're using and why. Okay, are you using a Bunsen burner to warm it up? Are you using a water bath to actually melt the substance, which is a safer and better way of doing it? When you're doing the actual experiment, it's a good idea to take a photo to include in your report. It looks good. It's very good evidence that you actually did it as well. So take a photo of your equipment when it's all set up, when it's cooling down, okay? Important, what amounts did you use? How much stearic acid did you use? How much paraffin wax did you use? And why? Justify why. If you used 10 grams of stearic acid, why? Why not less than that? Why not more than that? I'm not going to tell you. Figure it out. Talk to your teacher. What initial values for the temperature? What initial value of temperature did you use? You can link that to your risk analysis. Yeah. What intervals did you use for? In other words, how often did you take a reading? Did you do it every minute? Did you do it every 30 seconds? Okay. This is where something like a preliminary experiment would come in handy. In other words, you do a practice experiment and then based on what happens, then you choose your initial values and your intervals. And the point is that at the end of the day, we want a clear pattern of results. So you should choose initial values and intervals that will give you a clear pattern in your results. How did you make sure that your measurements were accurate? And I'll tell you one thing, avoiding parallax error. If you don't know what that is, look it up. And of course, there should be a risk analysis, which should be done as a table. Results, basically tables and graphs, correctly formatted tables, correctly formatted graphs, nice and neat. On graph paper, labeled axes with units, title, nice curve which tries to go through as many points as possible. Identify any anomalies. If any results look crazy, then you don't go through them, but you identify them. The analysis is what we actually do with our results and explaining our results. You should determine the rate of cooling at 3 points on each graph, and that's, as I said in a previous video, that's the gradient, okay, before, during and after. The rate of cooling at the beginning, the rate of cooling as it's solidifying, and the rate of cooling afterwards. You should determine the melting point of each substance from your graph. You should describe the shape of the graph using mathematical terminology. Now, what I'll say for there is rate of cooling. When you're explaining the shape of section 1, section 2, section 3, talk about the rate of cooling. What's happening to the rate of cooling? Say what the rate of cooling means, what it's measured in, and describe what happens to the rate of cooling in section 1, section 2, and section 3. How quickly does it change? Okay. Then explain the shape of each section of the graph. For the middle bit, for section 2, very important, with diagrams. What happens to the arrangement of the particles, the motion, the energy, the forces between the particles, the bonds between the particles when a substance solidifies? Okay, that's an important bit. It must be there. Okay, with diagrams, what happens to the particles as the substance solidifies? If you're aiming for a distinction, then you need a good evaluation. Each of the points on this slide you should discuss fully. And I don't mean write a little sentence, I mean write as much as you can, and intelligent, good, relevant stuff. Okay? Basically, the evaluation is how good was your method? How do you know? What evidence is there? What evidence do you base that judgment on? And how could you improve it? Okay? How good was your method? Well, do the patterns that you see, does it match the theory? Is what's happening to the temperature, is that what you would expect to happen based on the theory you talked about previously? Do your values for the melting points, do they match online sources? Very easy to Google, you know, the melting point of stearic acid. How close is it to your value? What is the percentage difference between them? Do your values for the melting point match those of other groups in the class? Don't just put yours and other groups in the table. Have a discussion about how close they are together and how the other groups match the online source as well. By the way, with the online source, give a reference, say where you got it from. What sources of error were there in your method? Can you identify any sources of error? If there were any anomalous readings, could you explain possibly why they happened? How might they be avoided? What improvements could you make to your method so that you get a clearer pattern? I mean, for example, this may mean taking readings more often, okay, or more accurate results. And then what other changes could you make which might improve your results? For example, amongst any others you could mention, many others you could mention, is if your calorimeter didn't have a lid, might it have been better if it did have a lid? And why? Don't just say what changes you could make, justify them, discuss each one. Okay, as I said, if you're after a distinction, then really your evaluation, you should be aiming for a couple of pages for a very good evaluation.